This conference will now be recorded.
Hello friends, welcome to the next session on applications of data science. Now this is the first session for the data science class. So what we'll do is we will understand about different applications of data science. We will look at about how data science is used in the real world. We will concentrate on different types of data. So I'll talk about a few examples of data. So today's session would be so couple of sessions from now would be few general basic sessions which will talk about the understanding of data science. So once we get the understanding of data science, then we will deep dive into some of the mathematical concepts and some statistical concepts. Okay, so my name is Sitaram and I have around 15 years of experience in IT. And in specifically in the data area, I have around 8 years experience. I used to work as a big data architect for many years, and then slowly navigated into data science for the past 3.5 years. And I also do a lot of trainings. So training is my passion. So apart from my regular work, I work for an MNC. I also give a lot of trainings. So I collaborate with different consultant peoples and all, and then get people for trainings. And from an educational background, I have an MTech in data science from BITS Pilani, and I'm pursuing my PhD in IIIT Hyderabad, and I stay in Hyderabad. So this is about brief about me, and we will definitely know about me in more detail. Uh, but let us, without wasting any time, let us get into the subject. I would certainly be interested to know about you people, but we do not want to waste time just with the introductions. We will slowly understand about you people, like what is your experience, what technology you're working on, what is the reason for attending this course, and other things slowly as and when we get deeper. All right, so without wasting any time, let us discuss about applications of data science. So the data analysis was there for many years. So it is not a new thing. This was there for many years. A lot of people have experimented on this data analysis term. A lot of people are doing research work with respect to understanding the data quality, how data could be used for providing insights, how different algorithmic process could be applied on the data so that we can get a lot of insights. So a lot of work was happening. It is not a new thing. We might be doing a course right now, but that is certainly not a new thing. A lot of work is happening. A lot of experiments were done. A lot of graph visualizations, understanding of data, representations of data, how data could be used for future effectiveness. So a lot of work has been done. But what is very peculiar about current situation is a very it's in a current situation where it is coming with a deadly combination. The combination of availability of data, the combination of storage and the computation, and the algorithms which can bind all these things together. So we are seeing a deadly combination which brings all these things together. And when all these things comes together, you could do a lot of wonders. In early years, there was a lot of work happened on AI, specifically artificial intelligence, where they were trying to make use of data and make systems which can intelligently work. Early 1950s were the perceptron models. So this was the year where perceptron models 1957, where the early AI models were created. But again, it came into an AI winter. So 1970s and all, it was in the AI winter. The reason is because even the perceptron models, the very good algorithms were introduced for making use of data. The unavailability of data was a big challenge, right? So even how do you collect data, how do you store data? Those were all the huge problems here. So the storage of the data was a big problem. The systems were not equipped to store huge amounts of data, so the data was not available for running these AI models. So it went into something called as an AI winter. AI winter is the phase in which after a hype cycle there will be a low valley, in which people think that okay, the AI is useless, and this is not going to help us, and because we don't have the right amount of infrastructure, it will not be of any use. In early 1970s, that's what happened. Then somewhere in 1980s to 1990s, the new algorithm sets were created, specifically CNN models. So CNN are one of the popular deep learning models which are used for image recognition. Primarily, they were used for identifying handwritten digits. So you write A, B, C, D, 1, 2, 3, 4. So if I'm writing 2, it should understand this is 2. If I'm writing 7, it should understand this is 7. Some people write 7 like this, some people write 7 like this, but whatever way you write, it should still be able to identify that is 7, and it should predict that. Now, initial years were used for automatically distributing the postal cards. So if you see in postal cards, people write the pin codes, and the CNN models were trained to identify those pin codes and automatically segregate the postal cards to the corresponding locations. So that was the system which was created. It was really good. By the time 1980s, 1990s, the storage systems were pretty much adequate, and people were able to store a lot of image data and other things. But the problem was the computation systems were not fully equipped. For example, to work on image data, nowadays we are using GPU systems, but back in those days, they used to still work on CPU systems, which used to be very, very slow. So by the time the number is recognized and it is identified that this is a 7 and not a 1, it used to take a lot of time. So that also yielded into a second AI winter somewhere in 1990s to 2000s. So that is the second AI winter, which again came into came into the picture. What after that it does is, now we are in this new age, 2017. This is when Google has invented Google's TensorFlow. So if you have learned about TensorFlow, it's one of the popular framework which is released by Google in 2017, and this is one of the popular framework which is used for building deep learning models and other popular models. So in this year, they have invented to TensorFlow, and again it has started budding out with lot of hype. You could say hype and possibility and things like that. That now AI is going to change the world. So from then you have seen that a lot of people, a lot of companies have started working on AI. They wanted to revolutionize the way they look at the company's data. They wanted to look at the data and then try to do some analysis, get some business benefit and other things. And now we are in the stage like 2020, 2021, we are in this question mark stage, saying that does this increase does it gain the popularity, or does it fade away, or this will be a next bubble which will be bursting. If you ask me, because of these deadly combinations which I was talking, so first one is the storage. So thanks to your big data and cloud, we will talk about these terms in a great detail. So thanks to these two things, because of this, now we do not have the problem of storages. So now you can have so much of data, any limit data, we can do an infinite expansion of systems which can handle your data at a large scale, and that is possible. Second one is the compute is available. Now compute with respect to again the cloud and GPU systems, renting on demand, increase in renting on demand. So such kind of systems are now available, and because of this, what we are seeing here is we will be able to do a lot of analysis, whether that will be image data, video analysis, surveillance information, sensor information, any information, whatever we are gathering, we will be now be able to do a faster computation with respect to your GPUs. And last but not the least, is your algorithms. Algos. Your algorithms, now TensorFlow has come up with new algorithm, TensorFlow. Google has come up with TensorFlow. Like that, we have Facebook's PyTorch and other important algorithms. Now, all these good algorithms are open sourced. And because of the open sourcing of these algorithms, what is happening is it is providing the developer community to experiment a lot of things. Initial days, when these were not open source, you need to procure a lot of licenses and other things. It was getting very difficult for a layman developer to get his hands dirty on those technologies. So because the technology is not available, he even if he or she has some ideas, they were not able to experiment. But nowadays, what we are seeing here is all these new technologies provided by the big corporates, they are getting open sourced. When you're getting these open source technologies, what you see is you can easily easily take the technology, try it, see which one works and which one doesn't, and then based on that you can go deeper and do multiple things. So that's what is happening. So we are seeing that a lot of things are coming together. So from the storage perspective, from the compute perspective, and from the algorithmic perspective, all of them are coming together, and it is becoming a deadly combination, which gives us a hope that this technology is going to stay for a longer duration, right? So if you have any questions, so what I would recommend is, if you are having any questions, I will stop at some equal interval times, but I would recommend to use the chat window to post your questions so that I can look at the questions and answer them uh, as and when possible, right? So that is a good practice so that it would not hamper the flow of the class. So whenever you are having questions, please take a minute and put it on the chat window. You have the chat window in the system, so that you could use that and then put it in the chat window so that you can uh, I can answer the questions quickly. All right, so that's one part. So we have seen that the systems are there and we are able to create that, and now AI is going to sustain for a longer duration. With that understanding, we are seeing that what is contributing to this AI. So when we are saying a lot of data is there, a lot of data is um, kind of getting gathered and a lot of analysis is happening. What is contributing to this data? So let us see. Data is everywhere. Of course, this is a very common thing. Data is everywhere. A huge amount of data is getting gathered, and as the year turns, there's a huge amount of data getting gathered. It is the purpose. It is our purpose to see that how that business data is captured, stored, and processed. So that's what we are trying to, a lot of companies are trying to work. If you look at the type of data, so type of transactions which are happening, right? So primarily the data is captured by a lot of businesses, right? So when I talk about data, definitely there's a huge amount of data which is gathered, and that data is basically captured by the businesses. The business could be a bank, the business could be a retail company, and any other such kind of entities, where the primarily the transactional data is captured. The data is regular data, like if you take a retail company, the data could be how many kgs of rice sold, how many liters of oil sold, which products were sold the most, and which products are sold the least. So such kind of information it is generally captured in RDBMS systems. The RDBMS systems are your operational data stores, which basically capture all your regular data, the transactional data, and that gets captured in the systems, and we can build further systems to analyze the data. So we can build further systems which will be able to read this transactional data and can make some sense. Most of the transactional data can be queried using SQL queries. A lot of SQL queries could be written where we can apply a SQL query to retrieve information, to do some grouping, ordering, and things like that. And based on that, we can get some insights. We can take a lot of companies, most of the business data is representing this transactional data, and huge amount of systems, IT systems were developed for analyzing this. Be it be SQL for storing data, SQL for analyzing data, creation of data warehousing systems, application of nightly jobs, batch processing, or creation of data lakes. All of them are primarily based on this transactional data. Now, this is one primary area of data storages. Apart from that, we have so many other new data which are coming up. The other ones are audio and experimental data. See, audio data is where you are trying to introduce all these newer things. For example, you could see the Alexa, you could talk to it. You could see all the audio assistants like Siri, Cortana, and other things, where basically the primary focus is where we are making the machine understand human language, human speech specifically. And when we are able to capture the speech, identify the patterns of the speech, understand what is the speech, and do the processings like speech to text conversion, and use the text for firing some queries. For example, I ask Alexa, hey Alexa, what is the weather today? It should be understanding it should be understanding that, okay, the question is what is the weather today. So it first does the conversion from speech to text, and once it converts the speech to text, then it captures the text information, and using that it will do some firings in the back end. It might call some popular search engine to get some answers for that, right? Lot of work is happening, and we will see that in the coming few years you could do a lot of application in this page. For example, one speech to another speech, like a speech in English to speech in, say, Telugu or Malayalam or Tamil or Hindi, any other language. So there's a lot of work happening in the speech to speech translation, speech to text, text to speech, usage of a lot of natural language syntaxing, natural language understanding. So a lot of work is happening in that specific area. That is the usage of audio data. Now, coming to the experimental data here I'm talking about, you could have a lot of experimental setups that could be in form of research, or could be in form of data gathering, experimentation, and so on. So one popular case which I can take is the COVID vaccination. So when you are looking at COVID vaccination, a lot of statistical understanding need to be happening in the COVID vaccination. So imagine there are 1,000 patients and you're creating a new vaccine or probably a drug for COVID. The way you do it is you try to do some statistical inference. You try to do some sampling. You try to test the drug on the sample and try to see like how the drug is behaving on the sample. So the samples are called as clinical trials. So if the sample is responding positively for the drug, say like you have created something like covaxin and you're trying to see like how is it behaving on the sample, and if it is behaving properly, there are no side effects and everything is proper, then they will release out the drug for a larger sample. Of course, there are a lot of stages in between it where you could do multiple lab level tests, then you do clinical trials, and then you go into deeper level analysis. But what we are seeing is the experimental data is where you are trying to capture a lot of experimental information, and based on that you do a lot of statistical testing, like identifying the sampling, uh, performing the hypothesis testing, and analyzing how the hypothesis is good. So all those experiments will be done, and based on that, you extrapolate the results to the real world data. So that's what is happening with the COVID, vaccination or any drug release. So such kind of experiments are happening, and the data works as a very strong basis by which these experiments will happen. Next, applications of data, the video and image data. So I will talk about image data first. A lot of work is happening in the space of image data, specifically in the area of healthcare and media and other things. Now, you might have heard about Sundar Pichai's Google I/O speech, where he was talking about diabetic retinopathy. Now, diabetic retinopathy is nothing but a kind of a disease which basically emerges with diabetes, and initially it affects the eyesight. So people having a lot of diabetes, slowly they will lose the eyesight. And what happens is within the retina, there will be some cotton spots, which will be formed in the initial days. And as the months and years progress, the person will lose the eyesight. So if you are early detecting the diabetic retinopathy, there is a high chances that the person can be treated and will ensure that the eyesight will not be gone. So a lot of work is happening, and specifically Google has come up with an application called as Verily, and they have used diabetic retinopathy in the application, and they have given this application for free for two of the primary eye hospitals in India. One is Shankar Netralaya and second one is Arvind Eye Hospitals. So what they have done is they have taken this diabetic retinopathy detection to a mass scale. So using their reach, the reach of Shankar Netralaya and Arvind Eye Hospitals, they have taken this diabetic retinopathy identification to a larger scale, so they can early detect the people who are having this disease, and if at all they are identified with the disease, they could be given early treatment. So that was one of the very popular project by Google. It's called as diabetic retinopathy. If you want to search, you could go and search. But there's a lot of work happening in that space. I took one example, but there are millions of examples which use image data for doing a lot of identification, classification, grouping, and other things. It could be used in surveillance cameras. Even in the recent days, I've seen attendance system based on no touch attendance system. So you're not touching any of the scanners or any of the swipers. The camera would look at you, identify that you are the person who is eligible for entering into the premises, and automatically open the gates. So such kind of systems are created, and using those systems we could create a lot of intelligent applications. Now that is on the image data. Coming to the video data is used for a lot of surveillance related things. One of the popular example which I can take is recently we are working with IIIT IIT and IIT Hyderabad are working with the Municipal Corporation of Hyderabad for creating systems which can take the feeds from the traffic cameras and identify people or violators who do not wear helmets. So that is a simple task. So now what we want to do is we want to look at the video and look at people faces and identify whether the person is wearing helmet or not. That is an easy task, but if you can combine that task with identification of the vehicle number of the person who have not wore helmet, and then can automatically cut a challan to his or her registered mobile, and that creates a holistic application. So people are looking at creating video-based surveillances, identifying data, making computers to look at the world and taking some decisions, like maybe applying some fines and other things. So such kind of applications are created so that we could use that for better surveillance, better monitoring, and other things. So such kind of applications are used. Next, other types of data are different types of charts, graphs, and stats, and so on. Of course, picture speaks more than 1,000 words. So using pictures, there's a lot of analysis which is happening. So representation of data in terms of charts, pie charts, graphs, bar graphs, area graphs, and so on. A lot of work is happening in this space where we can analyze these charts, understand the patterns, and then based on the patterns, you can take some meaningful decisions. Such kind of work is happening, and these type of data types also form a crucial position in which all such kind of graphs could be used. So these are some of the data types. I have not covered a lot of other data types which involved in could be involving sensor information, involving the data which is pertaining to augmented reality, virtual reality, mixed reality, such kind of applications which is combining a lot of combinations of real world data and augmentation data. So all such kind of data forms as inputs to these data science applications. Using those data, we are trying to create a lot of applications, right? In fact, there are a lot of terms which I can discuss, but putting all the terms at this time, at the first itself, would actually scare people. So what we do is, as and when we go slowly, we will introduce new terms. We will understand why they are used, and that will help us to solidify our understanding. The basic terms which people get confused is the AI, ML, and deep learning. Now, people might have heard the multiple forums. They might have gone through might have gone through some of the learnings about this, but there is this subtle differences between the way these different technologies are related. Now, what we are trying to see is what is the commonality of these technologies. What does AI does, what does machine learning does, and what does deep learning does. Now, we are trying to combine all these multiple things and then see what is the difference between every technology and what is the use of one technology and the other. If we talk about AI, artificial intelligence, now that is the basis for all the artificially made models and things like that. Primarily in the early years, AI was invented to kind of make some monotonous work. There was a lot of automated work, there was a lot of manual work which could be automated. So a lot of monotonous work, such kind of works which are purely based on some rules, some logics, some decision making techniques, and other things. Such kind of activities can be automated so that humans can do some other work. That was the primary focus. So primary focus of the AI was to create some techniques in which computers can take the work of humans by automating some of the tasks by identifying the logics and following the logics as a rule of thumb. For example, if you want to take a cardboard making company, so you are trying to make this carton boxes, so from a cardboard. Now you're given a piece of cardboard, and you are the worker who is turning that piece of cardboard into a box. Now what you do, you take the piece of cardboard, turn it to the right, turn it to the left, then make it some turns, twist and turns, and then make it like a box. Now, if you can list down all the steps, whatever we have done, we can say like, okay, take the piece of cardboard, then, turn it to the right, make a groove, and, turn it to the left, make another groove, twist it, and then do some other steps. So there are sequence of steps which generally a human worker follows. If we can take all those rule steps and can automate and give the instructions to a robot, a robotic arm, what the robot can do is the robot can perform the same thing. So AI, initially what happened is a lot of artificial intelligence systems came where the primary focus was to make the humans get out of this work and make the machines do the same work which the humans used to do. But for that, people, you need to provide the logic, people need to provide the rules, people need to provide the steps. So there should be some subject matter expert, some SME, who is kind of drafting all the steps and giving the machine with some instructions. It gives the machine with some instructions, some coded instructions, could use some language. Initial days, people used to use MATLAB and Java and other things. Nowadays, people are using Python. But what we do is we will try to create a sequence of coded steps which the system would use and can make some outputs. Now, if you're seeing, that is much more handheld. People are trying to create the rules and other things and so on. That was the initial basis of AI systems. Slowly what happened is the data grew. If you're having few records, now you could identify the pattern, identify the important features, and you can say that, okay, if this is more than this, do this. If this is less than this, do that. Now you can give this decision making easily. But if the data is increasing, it becomes very difficult for a human to identify all the patterns, determine all the patterns, goods and bads, yeses and nos, and trues and false, and provide an output. So for that, people have delved deeper and understood about something called as, I'm sorry. So they have done something called as machine learning. Now, what is machine learning? Now, machine learning is a subset of AI. If you're taking the AI as an umbrella, machine learning falls under it. And what it does is, instead of uh, humans providing all the sets of logic, rules, and other decisions, what it will do is it will use statistical techniques to identify the rules by its own. So algorithms, what it will do is it will try to identify these patterns. Now, identify the data patterns, create the rules from the patterns, and use the rules for doing the further predictions. Are you understanding? Here, the machine learning uses, because the data is increasing, huge amount of data is there. Instead of a human looking at all millions of records, identifying the patterns of the millions of records, and coming up with a generalized understanding, what the machine will do is it will use some of the popular algorithms. Algorithms could be simple algorithms like k nearest neighbors, decision trees, could be even complicated algorithms like random forest, support vector machine, deep learning based models, and so on. But what we are trying to see is we are trying to apply these statistical techniques in which we can enable the machines so that the machines can create this set of rules by looking at the statistical data, and based on the rules it can construct a generalized understanding. The generalized understanding is called as a model. So it constructs a model and uses the model for further predictions. Are you understanding? So here the machine learning uses these model building by using the popular algorithms, statistical techniques, and use this model for further predictions. Now we take a further step. Now we look at deep learning. Now what is deep learning? Now, machine learning primarily focuses on on data which is structured in nature. So data is structured in nature. Most of the data, I won't say everything, but most of the data is structured in nature, and it will have proper rows and columns, and then you could do some transformation of data and use the data for predictions. That is good. Coming to the deep learning, deep learning is a subset of machine learning. This deep learning is a subset of machine learning, which will work on specific kind of data points like speeches, image recognition, right? Multi-layer neural networks could be used. There are specific models like recurrent neural networks, convolutional neural networks, um, you know, adversarial networks, and so on. So all these different deeper modules which deep learning involves uses these higher dimensional data with respect to speeches, image samples, spectrogram images, and other things, video analysis, stream information. All those things will be used in deep learning for doing future predictions. Now, if I show a video of a cricket and I would like to identify, the machine should identify whether that is a square cut or a leg cut, or it's a 6 or a 4, or it is a wide. So it should identify based on the based on what is it looking, and it should be able to identify all such kind of data points. Now, if it is able to identify such kind of data points, now that falls under deep learning. So AI is a generalized term. Now it is getting even more generalized. Initial years, it was used to apply rule-based changes. Slowly, as the data increased, the number of data points are more, so we could not directly use that thing. So machine learning came into picture, where it can use a couple of algorithms to create generalized models. And one of the machine learning technique, which is called as neural network, which is very popular in predicting these high spatial data like images, videos, and other things. Those data points could be identified by deep learning. Right? We got about AI, machine learning, and deep learning. Now people will ask, like, okay, this is good, AI, machine learning, and deep learning. Then where does this data science fit in? Now, what is the data science? Now we are learning a course on data science, but where does that fit in, right? So AI, machine learning, and deep learning, they are the core part. They are the core algorithmic part, but somebody need to bring data to this. So imagine this is an algorithmic part. You need to bring somebody to do data ingestion. Someone need to do data processing, right? There could be some transformations, right? So there are a lot of connected things. Now you need to create a model, deploy model on cloud, right? You need to create an API for consumption. You understanding? So you need to create some batch process for you to create a pipeline for a batch process, so that every day these models work, and they pick up the model, uh, and basically take the model and deploy it and use it and other things. So you have a lot of these connected points, as you're seeing, right from the data ingestion to the uh, procurement, or basically usage of the model. You have a lot of connected things. When you're seeing a lot of connected things, now all these connected things could be used for could be they are the part of data science, right? So right from the data ingestion, so where is the data stored, where is the data ingested from, what are the data sources, how do you ingest data? Now once you ingest the data, it will be in the raw format. How do you format the data, how do you process it, how do you apply transformation techniques, standardization, encoding, scaling techniques, other things. Once you process that, then you give the data to your one of the model. Let us say like you apply one of the machine learning model, it creates a model. So once the model is created, how do you deploy into one of the cloud environment? How do you ensure that an API is created so that data could be taken from front-end applications like web applications or mobiles, and then and how do you create an entire batch process so that you can run jobs every day morning 6 a.m. you run a job, so that which takes some data, process it, give some output, and then create a report. So you want to automate this entire process. So for doing all these things, we would use data science. Now data science is not one single element, it will combine all these dots and then kind of create an entire system. So from a business standpoint, business will not say like, okay, use this complicated neural network deep learning based algorithm to find out so and so things. A business is not worried about that. They say that, okay, I have this problem. Now I would like to identify how many people will be eligible for loan, and if they're eligible, what are their eligibility limits. Now this is the business question. So when to answer that question, we need to gather a lot of information, we need to process a lot of information, apply some of the algorithms, create a model, deploy that with the front end web application of the bank, and do all the things. For doing all the things, you would involve the entire tool set. That is what comprises of data science. And during our course, what we'll do is we will divide that entire sequence into different buckets. Now we will start from as simple basics as possible. So we'll start with mathematics. We will discuss about statistical part. Then we will get into the tools for data science like Python tools, NumPy, Pandas, Matplotlib, Seaborn, Jupyter Notebook, and other things. So we will learn that, and then when we go into the modeling part where we understand about machine learning, we will divide that into many sub areas: supervised machine learning, unsupervised machine learning, reinforcement learning, and so on. Then we'll talk about natural language processing, then we'll talk about deep learning. So likewise, we go from very basic till the advanced topic, and as and when we get new topics, we will add it on the board. And what we do is we will do this entire course in a project-oriented manner. That means that every algorithm will be associated with the project. So as we are doing the project, we will understand about all these algorithms in a greater sense, right? So that is the scope. So any questions on whatever we have learned so far?
Yeah,
Yeah.
yeah. So there's a lot which is happening under the umbrella of AI. I do understand, and then we have various computational models which are getting released in the market, and the deep learning is actually doing micro analysis in terms of classification and regression.
Right.
It's trying to mimic the whole data there without even understanding what kind of mathematical equations go into building model.
Right.
Whereas the interpretability and explainability is missing there. Right? It's just mimicking the data. Right? And we are just back propagating through calculus methodologies, the basic calculus methodologies. Maybe we would have a quicker convergence through, the Adam optimizers. We have, softmax. We do back propagation, but in reality, we are not able to do any kind of interpretation or explainability on why such decisions are taken. Would you be able to throw some light on it? We do understand the basic business understanding, data cleaning, missing the value, KNN imputation, rescaling, so on, transformations based on the mathematics of the inference which we draw from the visualizations. Right? When we have a visualization coming up, whether it's an exponential visualization or whether it's a parabolic transformations based on the mathematical intuitions which we have by looking at the data. That's what we do, manual differentiation of these aspects.
Right.
And also we do some kind of data relationship, whether it's cyclic data, whether it's ordinal data. Do we have the normal one-hot encoding style of data pattern, depending on the relationship, what kind of data we are looking at, so on and so forth. So from a realistic standpoint, are we really getting the interpretability? Of course, we do a lot of transformations on it, but in real life, can we relate these transformations? Can we explain these transformations?
Yeah. So
yeah, on this in terms of research. I do understand you're working with IIIT, so you might have coordinated with a lot of researchers who are looking at state-of-the-art models.
Right. Yeah, I'll put some I'll shed some light there. So the terms might scare everybody, so I would like to go in a very general sense. So a lot of tools and technologies are used when so for everybody's understanding, the explainability of AI is nothing but, now when I use a model, when I use an XYZ model, now I just feed the data to it, and that model's algorithm will try to identify the pattern of input and output, and it will try to create some kind of generalization. That means that it will try to do some prediction, saying that if I give a new data, it will be able to use that understanding to do future predictions. Now that is how the whole basis of AI, machine learning, and deep learning works. Of course, the complexities of the data changes, but the whole focus is that. So in the recent years, people came up with the explainability of AI, which says that if I'm making some decision, I need to have some backup saying that, okay, this is the reason you are making so and so decision. Especially it is very important in healthcare domain and financial domain, because you are making decisions based on some XYZ model, and the model could be very wrong. You need to really understand why the model has made the decision. Especially healthcare, if you're saying somebody is having cancer because of the XYZ data, they need to have a proof saying that because of this particular element of your body is high or this is low, and because of that you're making so and so decision. Earlier models of machine learning was having that kind of explainability, specifically the tree-based models, where you will be able to interpret the data based on the trees structures and identification of transformations. So those all things are having explainability, and people who are still using base models for getting to these higher level interpretations. But when these new algorithms came, there are a lot of new algorithms like deep learning models, and where you can simply give an image data, video data, and text data, and based on that, it will try to come up with some output. The TensorFlow, one of the model, one of the framework, is working on coming up with some TensorBoard-based visualizations, which is not foolproofly providing the explainability, but it is at least able to create some graphs, create some patterns in which it will try to identify the important features which are contributing towards the output, and then trying to kind of pinpoint the areas which are telling like, okay, this is the reason we are giving so and so results. So there is still, it is work in progress. I will not say that it is foolproof, but there is a lot of work in progress from an explainability standpoint. But if you, on the other side, if you're seeing from a business standpoint, a business is also really quickly wanted to get the results. So if you really talk to any of the business folk, they'll say that, okay, I have this data. So I want to do this prediction. Say like I want to predict people who are eligible for my marketing campaign. Now I do not really worry whether they are really interested in my product or not, but I want to release that. I want to use machine learning, deep learning for capturing people who are interested in my product. Now, they might be spending millions of dollars on those marketing campaigns, and now they want to speed up the process by augmenting that with the data. So they come up with this explanation that, okay, I understand that I do not have the explainability that why the person is interested to buy my product, but still I wanted to apply these models, quickly apply the model and then get me the results. We will then further later, analyze why this guy is interested or why this girl is interested, right? While the research is focusing on the explainability, the ethics, and other things, businesses are, fast forwarding with their business requirements, getting some agile methodologies to, quickly create models, deploy them, get results, and so on. So there is a slight disconnect in the way things are moving up. But this research perspective, there's a huge amount of work is happening, understanding models and why a specific model is behaving so and so, which is a deeper field. So I will certainly talk a lot of points on that, but at this moment, it will be a little too deep to discuss that. Right? I hope you understand.
Yeah. Sitaram, most of the people who are on this chat predominantly try to serve multinational organizations, wherein each and every country, they've got their own laws and regulations,
right,
which enforces their business units or corporations to provide explainability on why such a decision was taken. And in fact, we, being in a developing economy, we rely on source of revenue generation, which is in a developed economy.
Mm-hmm.
And the overall business model in terms of IT or providing any kind of AI service to a multinational organization works based on the difference in the currencies.
Mm.
Hope you understand, right? That's how the organizations are operating at an offshore development center.
Correct.
So when we try, and if we do not incorporate conditional probabilities, say for example, basic Bayesian optimization, how would you think we will be able to add value going forward to these corporations in helping them defend from a regulation, from a law enforcing standpoint? Say basically, let's talk about GDPR. Okay. That's a privacy issue, right? That's, anyways, we have surpassed that and we've crossed in terms of extracting behaviors, and we are able to take that insights. But the data stays there in that particular geographic location. That's what Spark is doing basically. We're just sending our programs on the data, computing it, and then getting the behavior back. However, when the law gets more and more rigorous, how do we provide that explainability?
I certainly understand. So you see, I'm not saying no. I understand that. What I'm saying is the research is working currently. There's a lot of work happening there, but at the same time, people are also
the problem is we don't want to put these corporations into a diplomatic or diplomatic situation wherein they are struck up, because with a lot of difficulty we convince a business owner to adapt to AI and ML, and we don't want the AI to go into winters again. We have already seen 2 winters in the past.
Right.
I hope you understand that.
Right. Yeah.
We as the audience would like to bring in a lot of robustness in terms of defense as well. If something goes wrong, as a fallback option. Yeah. So that's the point which is driving across.
Right. I absolutely agree. But to this discussion, what we have just started, right? So we're just trying to understand some basic terms, and as we go deeper, we can certainly discuss more on those terms. Certainly, we would require a couple of sessions just to brainstorm possibilities, what current research is doing, and other things. But at this moment, I would like to break that for the view of other people. I'm sorry.
I'm sure it's full-fledged, full-blown model with all defenses in place. Usually, a country, if we are trying to defend diplomatically, we always have fallback options in place, right? Are we fully equipped with all the mathematical computations in terms of various different areas? Let it be socialist approaches, let it be econometrics which are coming into play. So we have all the models in place ready to defend ourselves in what my concern is. Before we adopt anything or before we start reading or learning any science, and where are we in terms of research? So we have all these in place.
Yep, I got it. Yeah. So
because the time spent has to be worthwhile. If it again gets into winter, the whole time spent and energy, effort, everything will go in vain. It has to be sustainable science from a long-term perspective.
Right.
Yeah, that's it. I have. Sitaram.
Yeah.
Hope you are far more knowledgeable in this area. You will be able to give more light on this.
Yeah. So definitely, I would give my piece of information, whatever I know, both from research point of view and both from industry point of view. So that's what I would like to do. I just would like to give a minute for other people. Anyone else have any questions? See, generally I have a hard stop at 8. 7 to 8 is the session. I would generally stop at 7:45. The session I will continue for 45 minutes, and I'll give like 10-15 minutes for anybody. If you have any questions, we could discuss certain things. And if there is a topic, definitely we will park it for the day, and we will resume it at the next day. Uh, Apologies because I have back-to-back sessions. I have a 7 to 8, 8 to 9, like that. So this is the first session, so I just want to make you guys comfortable understanding the topic. What we'll do is we'll come back tomorrow. We will understand some more examples about how data science is used in which areas. Specifically, we'll talk about some of the important applications. Any other questions? If you have, just you can use the chat. So it would be a 1 hour session every day. So daily 1 hour session from 7 to 8. At 8 o'clock, I have another session. Yeah. All right, I hope you got some insights. So we have a lot of points to touch. Definitely in the first session, we'll not be able to do that. Slowly we'll go deeper. We will understand about multiple other things. So in the tomorrow session, we'll understand about different applications, how data science is used in different industry verticals, what are the application areas, what type of algorithms are used, different techniques. Those things we will understand in tomorrow's session. All right, till then, take care and have a nice day. I'd love to see you tomorrow. Bye.
Thank you, Sitaram. Such a session has been wonderful.
Thank you. I appreciate it.